Charters After Pursuits. Mr. Lawrence here, and I hope you're able to watch this. We've had some problems with the sound, and that whole thing is really causing a lot of feedback. I had a video that works fine on my computer, but on YouTube it just sounds terrible. You can't even tell what's going on, and so I'm redoing this at 20 after 4 on Monday, so hopefully you'll be able to get to see it before tomorrow. All right, so today we're going to do some more mixture problems. This time we'll be doing coins and currents. Let's get right down to it. Jenny has some quarters and nickels. In all, she has 110 coins. The value of the coins is $8.90. How many of each coin does she have? All right, well, I'm going to set up my chart just like I did with the chemistry problems. And I had first bottle and second bottle. Today I have first coin, second coin, total. I'm concerned about the number of the coins, I'm concerned about their value, and I'm concerned about the actual money from the coins. So, how many quarters does she have? We don't know. How many nickels does she have? We don't know. How many total coins? She has 110. The first equation is simply Q plus N equals 110. The value of a quarter, we do know. The value of a nickel, we also know. We don't worry about the total value. We're going to put that down here. Now the money from the coins, I guess there should be an S on there, would be 0.25 times the number of quarters there are. And then we'd have 0.05 times the number of nickels, and all in all that is equal $8.90. All right, so my second equation is 0.25Q plus 0.05N, and that's going to equal $8.90. I think I'm going to go substitution to solve this system. I'm going to solve for Q, and I know Q is going to equal 110 minus N. So I'm going to do 0.25 times the quantity of 110 minus N plus 0.05N, and that should equal $8.90. Going to distribute here, and I'm going to get, let's see, half of 110 is 55, half of that is 27.50. Yeah, it's just a quarter. I didn't need to take a quarter of 110, so I cut it in half, and I cut it in half again. Minus 0.25N plus 0.05N, and that should equal $8.90. All right, let's combine some like terms over here on the left-hand side. It looks like I'm going to get negative 0.2N. And then I have to do 890 minus 2750. Well, let's think about this. 2750 minus $9 would be $18, right? Oh, 1850, excuse me, silly me. 1850, okay. But we're taking away 890, so 10 less. So it's going to be 1860. Now, it's not 2750 minus 890, it's 890 minus 2750, so it'll be a negative answer. Okay, negative 0.2N, divide by negative 0.2, sorry, ignore that. Divide by negative 0.2, and I'm going to get N, and I think if you do the math, you're going to come out with N is 93. Okay, well, the number of quarters, 110 minus 93. Okay, well, I'm thinking 17. Yeah, 17. So, Jenny has 93 nickels and 17 quarters. Now, of course, you can check this. Multiply 17 times 0.25, multiply 93 by 0.05, add them together. If you get $8.90, we did it right. I'm going to leave that up to you. Okay, now a current problem, which Vinny says is really difficult, but they're really not. I'm not going to use a chart on this one so much. Okay, I know that a boat travels 60 miles downstream in 2 hours. I know the return trip upstream takes 3 hours. What is the speed of the boat in still water? What is the speed of the current? Well, think about this. We got this little river here, right? And we have a boat. Okay. It's a motorboat, but I wanted to draw a sailboat. And so it's moving down the stream. Okay. Downstream is going to be with the current. The current is going to be pushing it along. It's going to be speeding up. So what's the speed of the boat initially? Well, I don't know. So I'm going to let B equal the speed of the boat. I don't know the speed of the current either. I'm going to let C equal the speed of the current. Right? Okay, so now I know that going downstream, I'm going to do the boat speed plus the current speed. Why? Because the current is pushing it along. It's actually adding to its speed. I don't know what that equals yet. Just hold on. I'm going to go upstream. I'm going to do the boat minus the current because now I'm working against the current. The current is in my face, so to speak, kind of like a headwind, and it's going to slow me down. Of course, this only works if the current or the air or whatever it is direct tail or direct head, meaning like a headwind or a tailwind. If it's directly behind you, if it's coming from the side a little bit, then you need some more advanced mathematics we won't get into in this class. All right, now what is B? It's the speed, isn't it? It's the speed of the boat. What is C? It's the speed of the current. Over here I need a speed. Well, you know what? I don't see a speed over there, but I do see a distance. And I see a time. And if you heard me talking to, maybe it was Jake Stefan yesterday, we were talking about what variable, he tried to tell me to never use t, and I said, oh no, because I know that famous equation, distance equals rate times time. So let's hold off a second here. Let's go off on a small tangent, mathematical tangent. There's a famous equation that says that the distance you're going equals the rate or the speed multiplied by the time. And so in other words, if you're going 30 miles per hour, that is a rate. And you do that for 4 hours, right? Well, how many miles have you gone? Well, I've gone 120 miles. Now, by the way, let me just show you this. 30 miles per means divide 1 hour times 4 hours. Okay, the 30 times the 4 gives me the 120, right? But then there's hours divided by hours. See how they're in the numerator and denominator? The hours would cancel, leaving me with miles. And that's why my label is miles, mathematically speaking. Okay, so for this other part of the equation, I'm going to take the distance and the time, and I'm going to figure out the rate. Because if the distance equals the rate times the time, and I'm dealing with a speed plus a speed, or a rate plus a rate, I need another rate. Well, let's just solve for r. So therefore, the rate or the speed is the distance divided by the time. So let's go back to our problem. Oh dear, I've lost our problem. I know some of you are going, yeah, we don't have to do it. Wrong. Okay, so my distance going with the current is 60 miles. So I need a 60. And the time is 2 hours. And so my equation becomes the B plus C equals 30. Okay, now I need the B minus C. The return trip is the same distance, but it takes 3 hours, doesn't it? Okay, and so that will give me the equation B minus C equals 20. I'll add them together using elimination. I'll get 2B equals 50. Divide by 2. The boat speed must be 25 miles per hour in still water. So the boat speed or rate is 25 miles per hour in still water. Okay, now just to figure out the current, well, it's pretty much the same thing. All I need to do is plug it into one of these two equations. I mean, the guys are so smart. I think you could tell me that it's 5 miles per hour. Okay, the current speed is 5 miles per hour. That's it. That's it. It's really not that hard. You just have to do the distance divided by the time right here. Because you have a speed plus a speed, it has to equal a speed. Or a rate plus a rate has to equal a rate. A rate minus a rate has to be another rate. Distance divided by time. All right, that's the video. Hopefully this one works out, because if it doesn't, I think I might just cry. Mr. Lawrence signing off. Have a good night, everybody.